In this video, we're going to continue our walk through the periodic table, looking at each one of the elements in terms of the four identifying factors within quantum mechanics for each electron. So we are still in the topic of quantum mechanics, and during the last video lecture we stopped with neon. Neon, we found, was 1s2, 2s2, 2p6, each s orbital, 1 each s orbital, and the p's have 3, the x, the y, and the z, the last electron being the 2pz. So the next element that we would be looking at is sodium. Sodium is number 11 on the periodic table. So if we look at sodium and we start walking through the periodic table, we've got 1s2. Helium really belongs over on this side. Then we've got 2s2, 2, and then this area is the s. If I use our sheet, you can see that this principal quantum number 2 starts with the subshell of s, and we count over 2. Then we're still in 2, but now we've counted over 2p, 1, 2, 3, 4, 5, 6, 2p, 6, and now we're starting in principal quantum number 3. We're in the s, and we're the first element, so it's 3s1. The orbital notation, each s has 1 orbital. Each p has 3 orbitals, x, y, and z, and this s has 1 orbital. So when I fill in these two, it's got an up and a down spinning electron, an up and a down spinning electron. You can think of us as building the atom, starting from the inner part and working our way out. This 1s has 2 electrons flying around. The 2s, this superimposed on top, has 2 electrons flying around. The 2p has 2 in the 2px, 2 in the 2py, 2 in the 2pz flying around. And then now we're going to add in another spherical shape that's even bigger. That would be the 3s. This one is the 1s. This would be the 2s, and now we have the 3s. But the 3s in this case is just 1 electron flying around on the outside. For the 2p6, remember we go up, 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 the x up, y up, z up, and then down, 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 because each orbital gets half filled before complete. And then out there on the 3s, there's 1 electron sitting out there by itself. So the last electron for sodium is a 3s up electron. Now, if we break this up into its different principal quantum numbers, we have the 1 here, we have the 2s here, and now we have the 3s. What I want you to notice is out here for the 3s, there's 1 little electron. So the question would be, what does this atom want to do, and why does it want to do it? Well, at first you might think, oh, it wants to gain 1 electron and put it right here so it's all full. But remember, the third principal quantum number not only has the s's, it also has the p's here. So really, and you don't need to draw this, I'm going to draw it a little bit lighter, a 3p with 3 orbitals, x, y, and z, all empty out here. So this sodium does not want to gain 1 to fill up this. It wants to take and lose this 1 electron in order to empty it out. As soon as it empties it out, it drops back down to this, and then at the second energy level, it will be completely full. This is why when we look at a periodic table and we see sodium in column 1A, we know it wants to get rid of that one outer electron and become a 1 plus ion. So when I draw 2, 3, 4, 5, 6, 7, 8, this would be sodium. And we would have said, oh, it wants to get rid of this electron. So instead of having 11 protons and 11 electrons, it has 11 protons and 10 electrons. And now the Na turns into an Na with a 1 plus. Not because it gained a proton, but because it lost an electron. Well, now it makes sense. It's trying to lose that 3s up electron. It goes away. All of these are empty, and now it's got a complete. The word that we will use later is octet. It has a complete octet. 8 electrons at the second energy level. Now, let's look at the next element. The next element is magnesium. So, magnesium is 1s2, 2s, it's a quantum electron configuration. 1s2, 2s2, 2p6, 3s2. Why 3s2? Because it's the second one over in the 3s. Second one over in the 3s. On this periodic table also. Second one over in the 3, row 3, s. So when we look at the orbital notation, we have an up and a down electron. Orbital notation, an up and a down electron. 3 orbitals for the p's. An up and an up and an up, and then a down and a down and a down. And then the s, an up and a down. Someone might say, well, let's do the last electron first. 3s down spinning electron. Someone might say, oh, look, it's all complete. It's all full. Don't make that mistake. Remember, you've got the 3 p's out here that are all empty, so it's going to lose. What does magnesium like to do? It likes to lose these two 3s orbital electrons in order to be a 2 plus. Look at magnesium. Here is it 2a, 2 outer electrons. It wants to lose 2 electrons, those 2 outer electrons, to become a 2 plus ion. Why does it lose it? It loses those 2, and then now on the outside, principal quantum number 2, there are 8 valence electrons. Now, let's take a look at the next element. After magnesium is aluminum. One S2, 2S2, 2P6, 3S2, but now we're still in the third energy level, principal quantum number, third, but now we're in this section over here, which is the P's, and it's the 3P1. So now there's 1, 1, 3, 1, 3. X, Y, and Z for the P, X, Y, and Z for the P. An up and a down for the S, an up and a down for the S, an up, and an up, and a down, and a down, and a down, an up and a down, and an up. Aluminum is number 13 on the periodic table. Why is it number 13? Because it's got 2 plus 2 plus 6 plus 2 plus 1. 2, 2, and 6 make 10, and then 3 more give you 13. Between principal quantum number 1 and 2, and now on the outside, principal quantum number 3, how many total electrons are there? There are 3. That's why we put aluminum in column 3A, because it's got 3 of those electrons on the outside. 2 of them are in the 3s, and 1 of them are in the 3p. What does it want to do? Well, let's look. It might be tempting to say, ooh, maybe it'll put 1 here, 2 here, and 2 here. That means it would have to gain 5 to be complete. It's not going to gain 5. Instead, it's going to lose these 3 electrons. So it loses 3 electrons to have a full outer octet. Once it loses those 3, it'll have 8 on the outside in the second principal quantum number. And it'll have a 3 plus ion because you lose 1 negative electron, 2 negative electron, 3 negative electrons to become a 3 plus ion. The last electron for aluminum is the 3px up spinning electron. The next element is silicon. Silicon, we're going to walk through 1s2, 2s2, 2p6, 3s2, 3p2. 1 orbital for the s, 1 orbital for the s, 3 orbitals for the p, 1 orbital for the s, 3 orbitals for the p. As we go through, an up and a down, an up and a down, an up, an up, an up, a down, a down, a down, an up and a down, an up and an up. So 2 electrons here, an up and an up. Remember the rule. Each orbital must be half filled before any are completely filled. So we have to go up and an up. So the last electron is not the 3px down, it's the 3py up spinning electron. Silicon is number 14 because when you add 2, 2, 6, 2, and 2, you get 14 electrons, and you can see where all of them are. The atoms are starting to get big. You've got 2 electrons in the 1s, 2 electrons in the 2s, 2 in the 2p, 2 in the 2px, 2py, 2pz. Then in the 3s, there's 2 electrons. Now, in the 3px, there's an electron, and in the 3py, there is an electron. So the atom's starting to get bigger. Now, what is silicon going to do? It's in column 4A, so it has 4 electrons on the outside. Where are those 4 electrons? Well, 2 of them are in the 3s, 2 of them are in the 3p. So is it going to gain 4 to put 2 right there, 1 right there, and 1 right there? Or is it going to lose 4? These 2, this one, and this one. It's in column 4A. So it does, what we're going to find out is it does not gain or lose. We're going to find out that it will share electrons. It's right smack in the middle, so it's not going to lose, it's not going to gain. Then the next element is phosphorus. We're going to go through 1s2, 2s2, 2p6, 3s2, 3p3. It's the third one over in the p, 1, 2, 3. In the p, 1, 2, and 3. In this p section, 1, 2, and 3 in row number 3. So now we've got 1 orbital, 1 orbital, 3 orbitals, 1 orbital, 3 orbitals, x, y, and z, x, y, and z. We have an up and a down, an up and a down, an up and an up and an up, and a down and a down and a down, an up and a down, an up and an up and an up. So the last electron is the 3pz up. Phosphorus, on the outside of phosphorus, principal quantum 1, principal quantum 2, principal quantum 3, there are 5 electrons because it's in column 5 5A. That's why they put phosphorus here in column 5A. So the 5A, 3PZ up electron. What is phosphorus going to do? Because it's in column 5A, it wants to find one electron, and one electron. One for the 3px, one for the 3py, one for the 3pz. So what is it going to do? It's going to gain, it wants to gain 3 electrons to become a 3 minus ion and put those electrons in the 3px, 3py, 3pz orbital. Phosphorus. The next element we're going to look at is sulfur. Sulfur we are writing as 1s2, 2s2, 2p6, 3s2, 3p, and when you look at the 3p, it's 1, 2, 3, 4. It's the fourth one over in the 3p subshell. Each s has 1 orbital. Each p has 3 orbitals. So we have an up and a down, an up and a down, an up, an up, and an up, and a down, and a down, and a down, an up and a down, an up, and an up. Once each one of these orbitals is half filled, the next electron goes into the 3px down. So the last one is 3px down spinning electron. The 3px down is the last electron, and when we look at this atom of sulfur, you can see that it has 2 open spots, the 3py and the 3pz, both down electrons that you want to put into the 3py, the 3pz. This is why sulfur being in column 6A, column 6A for sulfur, you have 6 valence electrons. 2 here and 4 here give you 6 valence electrons. That's why it wants to gain 2 electrons. So it's in column 6A. It wants to gain 2 electrons to become a 2 minus ion. After sulfur is chlorine. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Each s has 1 orbital. I accidentally drew 2 for that s. The p has 3 orbitals. This s has 1, and this p has 3 orbitals, x, y, and z, x, y, and z. So now this s has an up and a down. This s has an up and a down. This p has an up, and an up, and a down, and a down, and a down. This s has an up and a down. There's 5, but we go up, 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 down, down, and we stop right there. That gives you your 5 valence electrons. So now we end up with a 3py down spinning electron is the last electron. Here on the outside, principal quantum number 3, you have 7 electrons. You have column 7A, so it's going to gain. We know that chlorine in column 7A, it wants to gain 1 electron to become a 1 minus ion. And then finally, to finish that row, we're going to be dealing with argon. And argon is 1s2, 2s2, 2p6, 3s2, 3p6. One orbital for the s, 3 orbitals for the p, 1 orbital for the s, 3 orbitals for the p. So we have an up and a down for the s, an up and a down for the s, an up, and an up, and a down, and a down, and a down, an up and a down for the s, and then there's 6, an up, an up, an up, a down, and a down. The last electron is the 3pz down. Now notice, in that third outer principal quantum number, there are 2 electrons and 8 electrons. That's why we place this in column 8A. Column 8A, it is completely full. Column 8A, it does not gain, lose, or share electrons because it is completely full. That's why we call this column the noble gases. They do not want to interact with other atoms by gaining, losing, or sharing outer electrons. I hope this helps in understanding the 4 identifying factors for each electron as we move through each element of the periodic table.